This demo is going to take our quadratic formula calculator program where we input values for A, B, and C and output the roots, and we are going to modularize it. So you can see what the output looks like. And then if we glance through the code over here, we have a section of code for declaring our variables, we have the directions, we have user input, and we have some calculations where the solutions are done, and then we have some final output, etc. And so we are going to work on rewriting this into modules in CSharp. And some of these modules I have pre-written and we might pop in here, but many of them we will kind of write as we go. So the first thing that I want to do is just basically take these directions and put them in their own module. So we need to do public, static, and it's going to be a void, and I'm just going to call the method directions, parens. There are going to be no arguments sent in, and nothing is going to be returned. And then what's going to happen is I'm going to take the code that we had for our directions and I'm going to just cut it and place it into our module. And there could be some argument on the comments here. Some people will, we need to comment our different sections of our code. We should do that. But if we also make our code self-documenting, then we might not need as many comments. Now, in order to call that method, in order to get that code to execute, we have to call the method with the method name. You guys have been doing this already when you use WriteLine. Right now, we are going to call directions, and every time we run through a little different part of this program, we are going to run the code so we can see if it executes correctly. And this also is kind of along the lines, not exactly, of testing each little individual part, or what we could call each individual unit of our program. We will talk about unit testing a little bit later. If you see here, I am getting an error message, and that error message is: this call is ambiguous between the following methods or properties: program directions. What you have not seen is I was playing around a little bit before we started this demo, and I actually have another method named directions after main and after the ending curly brace, because I wanted to see if the code would execute if I put the method below main, and it did. We are going to put them above main for right now, just because it's a little bit easier for us to see the rest of the code. Depending on what language you're in, you may have to write all of your methods before that main function call, or you might have to put them in their own code file, and we actually will learn that later in this course, but we don't need to worry about that now. So now that I have that out of the way, if I run or execute this code, I'm going to see if those directions show up and see if my method actually executed, and it did. All I'm really looking for right here is that those two things executed. Throw in some values. We do have an overflow, underflow error trapping in this program, and so that code did not actually work. Well, it did, but we didn't get a solution. Okay, so now, next thing. How do we then go about writing our next method? What do we want to do next? Well, the next piece of code that we have here, we had this was our directions if we put our comments in. And then we have user input. So we want the user to input A and then return a value. We want to get the value back for A. So on this one, when we write a method, we want to return a value back. So it's going to be assigned to value A. And I'm just going to call my method getInput for right now, just for a lack of a better thing. And I want to send it a value. I want to send it A. Because what I want you to see is that we have almost identical code. Enter A, code matches the code for enter B, which matches the code for enter C. And this is one of the kind of cool things, or the magic about using a method, is I can actually clean up all of these code blocks, or make all of the I can make one block of code that basically essentially does the same thing as what all of these lines of code will do here. So I'm going to write one of them first and see if we can get that to execute. I'm going to call it get input. We're going to send in a value, and then we are going to basically copy what we have here in our try catch for A. So I'm going to Control C, copy that, and that's what's going to go into our method. So our method is public static. I want to return a value, int. My method name was get input, and then I'm going to input a prompt that I'm going to use within that method. Remember, I'm sending in A. So I have my block of code here. I'm going to paste my previous code that I had written, but now I need to change it, so I'm going to enter a prompt here. So the first time I run it, it will be A. The next time that I run it, it will be B, and the next time it will be C. The other thing that I have to do, notice now A has a squiggly line. It says the name A does not exist in the current context. That's because A is not declared within this scope. A is declared within the scope of main. Well, I don't want to redeclare A here. I just need a temporary variable to hold my user input. So I am going to declare an integer variable named input and assign it our default value A, or excuse me, 0. I'm going to get that input and then catch for an exception. And then this particular method returns a value. So I have to return either the default, which we decided earlier was 0, or the value that was put in. So I'm going to return input. Clean up the white spacing in my code here a little bit, and now I should have a method that is going to calculate the value for eventually A, B, and C. Right now we are only going to calculate getting the value for A. I can delete all of the code for A, and I call get input. It will go up here, it will run through all of this code, and it will return a value. So if I execute the code just to test to see if this module runs, we will see if we get some inputs. All right, we have an overflow error. I'm not picking very good numbers right now for my examples. We'll try to get that a little bit better in a few minutes. But here's the deal now. I can do the same thing in order to get an input value for B, and I can call the same method to get an input value for C, and then I can delete all of this code that has several of those try-catch statements. The try-catch statements are important, but we're doing that within our method now, and if I execute now, it shouldn't look any different than what it did just a minute ago, but it's going to have be calling those methods. So input A and B and C. And now we got two roots. And so I just modularized that code. I can see maybe a little bit better what the program is doing here. I'm getting user input, and I can see I'm getting inputs A, B, and C. The details for how this is done is hidden within my method, which is up here before main. And so this method, and every time we write a method we should comment it. So this method will return an integer value given a prompt. Okay. Now we know it's for the quadratic formula, but in general that's what that method does. We should comment our first method, and this method will return or returns, no, it doesn't return anything. This method provides directions for the program. And it actually is a good habit to maybe repeat the name of the method. Directions is the name of the method here. Provides directions for the program. And get input returns an integer given a prompt. So we have both what that method does and what the inputs are and what the outputs are in our little comment. All right, now we're going to write a code in order to do the calculations. And there's a couple different ways that we can do this. The first way I'm going to look at is we're just going to calculate a single solution. So if I want to calculate a single solution, my solutions are doubles, so I'm going to return a double. And also, what do I need in order to calculate a solution in a quadratic formula? Well, I need my inputs, A, B, and C. So basically, what I'm going to try to do is say my solution 1 is going to be, and I'll just say find solution, and I'm going to input A, B, and C. So I'm going to send in the arguments A, B, and C. They will fall into the parameters for that method, and then it will return solution 1. So basically, I'm going to take all this calculation here and put it into that method. I'm not going to worry about solution 2 right now. I'm going to comment out. There's a way to a shortcut. So for right now, I just want to comment out this code. Control K, Control, and now I'm forgetting C, I believe, will comment out that whole section. So when we run it, it will run. And then I'm going to write this method for find solution. This is a method that takes more than one argument. So it's going to be public, and it's going to return a value. It's going to return double, and I called it find solution, and it's going to bring in an integer A, integer B, integer C. Now, even though I'm naming them the same, it creates its own A, B, and C within that block of code. I then want to just borrow the calculation that we need, which is the discriminant, and paste it in here. Not the discriminant, but the solution. Calculating the discriminant is part of the solution. I just kind of, actually I could write a module to calculate the discriminant. It's probably what I should do. And so we got a couple things going on here. First of all, I need to declare discriminant as a double. It does not know solution 1 within this local scope, because I might potentially want to use this for a to calculate solution 2 also, although that won't work. We'll explain why in a minute. I need to create this local variable. Because it returns a value, I need to return solution. And I'm not producing a bunch of error messages right now, but you're going to get all kinds of error messages, and you're going to have to learn how to kind of read them, because if I didn't put that return value in, it would not compile. I do have, it says I have an error up here. I don't know what that error is. Oh, it's because I have some other code here that we have executing in our error trapping. So I'm going to comment that out for now. Control K, Control C, and then also comment out solution. Well, solution 2 is not calculated. We're just going to comment that out for right now, and I'm going to cross my fingers that our code will run, and I'll see if I can execute that one block of code that will find a solution. Now we will not see the solution for solution 2 because I deleted that out, but if we run this, we do have a calculation for root 1, so it seems to be working. So now I have a decision to make. I could go back and do the similar type of a thing to calculate solution 2, but because of the quadratic formula where I have negative b plus the square root, yada yada yada, and negative b minus the square root, yada yada yada, it's not going to work as well or as succinctly. What I really want to do is basically borrow all of this code right here in order to calculate both solutions all at once. That's going to bring us to a different type of method that we can use. Methods can only return a single value, except if we use reference parameters. So let's see how this would change this program up. I can change the name of the method to find solutions, and I can add 2 more parameters. They need to be double. One will be for solution 1, and one will be for solution 2. In order to allow us to return two values, we actually need to make this a void method. So I will not have a return statement, but I will make these two variables what we call reference variables by adding a ref in front of it. What that does is it links these two variables to the variables in main that we are going to use to call this. We are going to send in solution 1, solution 2. In order for the computer to know that they're reference solutions, we do need to add the ref in front of both of these. And it no longer returns a value, so we don't have to assign it to anything. So we're getting closer here. It doesn't like a few things. One is the name. Find solutions is how I renamed it. And then solution 1 and solution 2. It is not liking right now because it says an unassigned local variable solution 2. So we're using that down here, etc. We are going to actually be taking this block of code. I'm going to cut it, Control X. We are going to paste it, and we already have some of it. So we calculated the discriminant. I'm not going to print the discriminant out, so we don't need that part. We calculated solution 1, and then we're going to calculate solution 2, and those values will be returned then back to main. And they're technically not returned because what they are is they're linked by reference. They're referenced back to those variables in main. There's another shortcut that helps you clean up your spacing. I could do Control K, Control D. I don't know if you saw it, but it cleaned up a little bit of spacing there. Always close up your white space, and we have to give ourselves a comment for this method, and it would be find solutions calculates the roots for a quadratic equation given A, B, and C. I do no longer need this local variable. So technically that should calculate our two solutions. It should send it back to where we were calling the method from. I no longer need discriminant in main because that's within my find solutions, and so the scope of that variable doesn't need to exist. Outside of there, I do want to uncomment my arithmetic exception here, so that's a Control K, Control U to uncomment, and we're getting really close. We just have a couple more errors here. Use of unassigned local variable solution. So what that's telling us is that it doesn't have a value before we send it to the method, and it's not sure that when it sends it to the method it's going to get a value. So we have to actually initialize these variables. And I don't know if you've seen declaring and initializing on variables, similar variables all in one line. I'm doing that up here on line 56 if you see that right now. And so that cleans up those two solutions. Cross our fingers, run this program. We have now written a method with reference variables. So we can get two values back to main. If I enter the values, I think I have that worked out, so it enters some stuff or gets us a correct solution. It looks like we are in business. It is looking good. If I run the program again, let us see if we can get a NaN error. See if our error trapping for infinity, which is done right here. We've done a little try-catch block to check for an arithmetic exception. And I know if I enter 0 for A that I'm going to get that exception. And so that executes. I also want to see if I run this program and I execute it. I want to look at the output and see what the output looks like for decimals. And so if I enter some numbers and we get some decimal solutions there. We got some decimals that they output. They're kind of messy because they run on forever. So the last thing that I want to do in this video is let's clean up our output on that just a little bit and show you again. We've showed you this once, but how do you format output is with the curly braces and then argument number 0, colon. Now this one is going to give us, I'm going to do 3 decimal places is how I'm going to do this in the curly brace, put in a comma, so then we follow with our parameter list or our argument list there for that. So that's going to output to 3 decimal places our decimal solutions and really kind of spiffy up that output just a little bit. So let's see what happens if we run this again. And we enter some values that will give us decimal answers. I have a mistake somewhere. Oh, I need to do a comma instead of the concatenation. So it looks like the program is executing correctly then. So what we have done is we took our original code and we modularized it. So now our program, quadratic formula program, and this is initial variables and defaults. Clean up my messages. We have directions for running the program. We get user input. We should put a comment in here. This section of code is calculating the solutions and error traps for bad data, and we have some output, etc. That's our program. So a couple of things. I'm going to do a Control K, Control D. That also just kind of reformats everything and clean up a little bit of white space. We have a method comment for each method, and it's looking pretty good. So we have 3 methods. I could have done more, but this kind of demonstrates. For example, I could have written a method for discriminant. I could have maybe tried to clean up this little bit of section, this try-catch block, but I decided not to. And so this was a rather long video, but it did demonstrate how to do several different types of methods. One that had no arguments and no return values. One that had 1 argument sent in, parameter, and then it returned a single value. And then a method find solutions that used reference variables to return multiple values, and it also had multiple parameters. And then we also got a little fancy with our formatting. That's a wrap. I hope that helped with your creating methods in C#.